All right, so this is part two. So how do we find our y hat? So I'm just gonna erase this for now. So y hat, gonna have to find six y hats, and this is why this process is very tedious. So we're gonna have to find y hat for patient one, patient two, patient three, patient four, patient five, and patient six. So we're just gonna plug these values into our equation for each patient. All right. So here's how it's gonna be written. So y1 hat, so 23.9073. That is our VO plus 0.33689 X1. So we're going to look at our first patient, and the X1 value is 5.1. Sorry, 5.1 plus. I'm going to do two of these or two more of these, just so that you understand how it works. Uh, Wait, sorry, 63 and 33. Okay, let me just calculate this real quick. Sorry, my formula, my calculator is bugging, but basically you're going to get some answer when you do this. And then you're going to repeat the same thing for Y2 with patient 2. We're just going to plug in the same formula of Y hat is equal to BO plus B1 X1 yada yada yada. The B1s don't change. The B1s are just the B1, B2, and B3. These are just what you get from here. BO doesn't change either, but the X variables do change. So when you plug the different X variables in, you will get different Y hats. All right. Now at the end, what you should get is six Y hats. Okay? And once you get six y hats, now you're ready to do your equation or do your SS error because that's why we're getting these y hats. We're getting them to be able to do SS error. So SS error, what did we say it was? We said it was the sum of given a given y value, given y values minus the sum of all y hat values, right? Yeah, that's it. That's it. That's it. So we have six yi's which are from this table right here. And you have six y hats that you would have calculated here. So you just do the sum. So you just do y1 minus y hat 1 squared plus y2 minus y hat 2 squared plus y6 minus y hat 6 squared. So that's just how you do it. And at the end, you should get SS error. So you have SS error at this point. You would have SS total. Now you just need SS regression. And once you get SS regression, you divide SS regression by its degrees of freedom, and you divide SS error by its degrees of freedom. And once you do that, then you just look at this table to find your F statistic. So F is equal to SS. Oh, sorry. SS regression is equal to SS total minus SS error. This is just me rearranging the equation where we had SS. So SS regression plus SS error was SS total. So I just rearranged this. So you get SS regression. Uh, so how do you get the degrees of freedom of SS regression? So df SS regression is equal to k, and k is number of x variables, which we said was 3. And the degrees of freedom of SS error is equal to n minus k minus 1, where n is our sample size, so sample size. K is number of x variables, and minus 1 is just there. So we have 6 patients. Wait, we have 6. Okay, this is weird because this is 5 patients, and here it says 6. So I'm just going to assume it's 6. 6 minus, because we have 6 values, so I'm just going to assume it's 6. 6 minus 3 minus 1, which is equal to 2. Okay, so you divide SS regression by 3 because its degrees of freedom are 3. You divide SS error by 2 because its degrees of freedom are 2. And yeah, that should be your F statistic. So you should get a value of, what is it? Of 2.98, which is, yeah, that's C. So yeah, it's a very long and tedious question. The only thing I need to worry about is putting all your numbers in a calculator right. It's not a hard question, it's just long. It's nothing that we haven't seen before. There was one thing, right, where there's one really short way to answer this. We weren't able to do it because they didn't give us the value. But if they gave us this multiple r squared, they gave us adjusted r squared. If they gave us multiple r squared, then we could have used this formula. We could have gone SS total, and when we got SS total, we could have gone SS regression. When we got SS regression, because obviously SS total we saw it didn't take long. If we got SS total, right, we could have gotten SS regression immediately by just timing this by this and rearranging this formula. And if we got SS regression and SS total, then we could get SS error and divide by the degrees of freedom, and that wouldn't have taken long at all. So we wouldn't have had to calculate much other than SS total, which we saw didn't take long. But obviously, the professor had to make it hard, which is why I said that this part right here, under this table, so this right here, can be important. It can be. So you really got to check it to make sure. This part is always important. This is your B0, that's your B1, B2, B3. So this part can be important depending on the question. Here, unfortunately, it wasn't. They gave us adjusted r squared value. You could do a formula to get just the regular r squared value, but we didn't learn that, so I don't think that. Well, you can still do it. It's not a method that was taught to us. Um, so yeah.